University. We can do that. Okay. We are now recording. Let's go from current slide. All right. Now, before we get going with that, we had a couple of these announcements. I think you've heard them all. You did hear about College Transfer Fair Days coming up in February, both campuses. If you want to see what schools have been invited and the days and times, they're all here. Okay. And then this is something I highly encourage any of you, especially if you're thinking of engineering, specifically mechanical, electrical, or material engineering, a great summer internship program. Okay? It's a 10-week program, either at University of Illinois, University of Arkansas, or Howard University. They will pay you $5,000 to go learn a whole lot of stuff. What a deal. That's $500 a week. In addition to that, they will house you for free. In addition to that, usually when you're in the dorm, you get a meal card. They'll feed you for free, and they'll pay your airfare up and back. Quite a good deal. It's a National Science Foundation grant, so that's how they have that much money, and they are really looking forward to applicants. And that deadline is February 15th. So don't wait. Start working on that deadline. Got 2 pages of information here. You're certainly welcome to look at it. This is a little brochure that I sort of pushed together of what they said. The main information is here. This I can hardly read, so I don't know if you can get much out of that or not. But it is on the inside. I recycle paper, so it's on the back side. Okay. All right. Next, any questions for anything we've done so far? All right. If not, here's where we left off last time. We were talking about the domain of a function. Okay? There are some domains that are explicit. They just tell you what the domain is. Okay? Others are implied. And we talked about one last time that was an implied domain. And what would create an implied domain? I'll turn back to it. Anytime you see the variable in the denominator. What do you know about denominators? They cannot be zero. So you have to investigate and see if any value of that variable x will make the denominator 0. If it will, exclude them. Otherwise, we're going to assume all real numbers except any excluded values. Now, can anyone think of another mathematical operation that you have limited things you can do with it? You can't divide by 0. We know that. Is there any other mathematical operation that you can't do on certain numbers? I think all of you know it, but you may not be thinking of it yet. How about this? Any restrictions here? What about a square root?
You can't square a number that's good.
Say again?
Yeah, you can square perfect numbers.
Yeah, what values for x would be limited there? Any? Do you take the square root of any number?
Well, square root of 4.
That's fine.
Square root of 6.
Okay, that's good.
8.
Yeah. Those are all good. Let's go the other direction.
So that's imaginary.
Say again? Okay. What gives you an I? If you try to take the square root of a negative number, can't do it. Okay? Now we're dealing with the real number system here, not imaginary numbers, so you cannot take the square root of a negative number. Can I get your name, please?
Graham.
Second. Graham? Okay. Oh. Okay. Oh, okay. I could not read what you go by. Grant?
Dre.
Gray?
Dre.
My hearing's terrible.
Dre.
Drake. Okay. That's what I thought I had written down. And then when I saw your name, I said, did he really say Drake? Okay. B-R-A-K-E. All right. Got it. Anyone else come in since I called roll? Snuck in when I was at work. Okay. All right. So, anytime you have a variable in the denominator, you have to investigate, exclude all values that would make that denominator 0. Anytime you have a variable in a radical, square root, not just square root, 4th root, 6th root, 8th root, 10th root, what's all these got in common? They're even roots. Any even root, you cannot take the square root of a negative number. Odd root, square root, cube root, 5th root, 7th root, no problem. But it's only even roots. And if you don't see, now this is one of the few things. If you don't see a coefficient, what do you assume it is? 1. If you don't see an exponent, what do you assume it is? 1. If you don't see a number inside a radical, what do you assume it is? 2. Okay? This is the one index that you don't usually list if it's a 2, but if it's 4, 6, 8, 7, 4, 15, whatever, you put the root in there. So if you don't see an index, you understand it to be a square root. Okay. Only time it's not a 1. Okay. So this is defined only for x greater than or equal to 0. That's the shorthand way, math way of saying it can't be negative. Okay? It has to be greater than or equal to 0. You can take the square root of 0 as 0. So its implied domain would be this. Now, I did mean, we ran out of time last time. Let's go back. Now I remember. The way they wrote this, to me, is pretty simple. They wrote it, let me get my pen set up. Okay. They wrote it this way. Has an implied domain consisting of all real x other than x equal plus or minus 2. That's a lot of writing, and I'm way too lazy for that. So there are 2 ways, shorthand ways, that you can express that domain. One of these is set notation. Okay? And in set notation, this would be the set of all possible x's, this is how you read this, such that x is not equal to plus or minus 2. Now that's a lot shorter than writing all those words. This means the set of all x's such that, that's the vertical line means such that, x is not equal to plus or minus 2. The way they worded it is all real numbers other than x equal plus or minus 2. Much shorter to say all real x's as long as x is not equal to plus or minus 2. So that's a very shorthand way of saying it. The book likes what they call interval notation. I'm surprised they didn't show it here. Does anyone know what I mean by interval notation? Okay? Here's what I think, how I think of interval notation. Okay, we're talking about x's. Where does x usually show up on a graph? Horizontal axis. Okay, so let's draw us a number line. Because that horizontal axis is basically a number line. That's supposed to be a line. Okay, 0 is somewhere in the middle here. We'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3, 4, 5, 6, 7. Okay, and go on and on and on. Okay, there's your number line. Okay, all real numbers on that line. Now, if you're excluding x equal plus 2, open a circle there. X equal minus 2, open a circle there. All other values on the number line, all real number x's, that's everything here except that one. So you'd have all these, and all those. Okay? So, interval notation is going to say that a lot more shorthanded than this. Okay? Does this ring a bell? Where is it coming from? Way down this way. Way down this way. What does that represent? Way down this way. Negative infinity. So it's coming from, the domain would be negative infinity. Now, anytime you're dealing with infinity, always use a parentheses. From negative infinity, and how far does it go before it hits a bump? Negative 2. Do you include negative 2? No. So you put a parenthesis there. That means you do not include the negative 2. Okay? But we will include, second, Fuller? Okay, Latrissa, right? Okay, good deal. Does anyone else come in since the call roll? Okay. Now, that covers all of these. So I'm going to put a union that, meaning in addition to this, we'll lose, and where does it pick up? From negative 2. No, don't go there. You have to include all these in here. So it picks up from negative 2, not including negative 2. The parentheses indicates do not include the negative 2. Okay? So here's that parentheses. And it goes how far? To 2. And what symbol? Parentheses, because you do not include the 2. Now we're going to union that interval with, where does it start then? At 2 again. So parentheses, because you don't include the 2, to how far? And what symbol do you put there? Parentheses. There it is. Now to me this is longer and a little more involved, but this to me is shorthand. The book likes this one better than this, it seems to me. Or you can write it out like they did. That's the longest way. Okay. So, the reason I brought that up now is this is a little more complicated case, but I wanted to show you both of those. When they come over here, here is that defined only for x greater than or equal to 0. So if I were doing this in set notation, I would say the set of all x's such that x is greater than or equal to 0. It's just right there, okay? Now, here they give the interval notation. That's it. Why didn't they do that on the other one? Okay? Now, what do you notice different about this one? Yes, it has a square bracket here, which means you include the 0. Okay? A parentheses would say exclude the 0. The square bracket means you include. It has an equal sign there. If this had been just greater than, you would have had an open parenthesis. Does that make sense? And all greater than, this means it goes to positive zero. Make sense? That's two ways that you can express shorthand domains and ranges. Okay, whatever. The implied domain is that interval. In general, the domain of a function excludes values that would cause either division by 0 or that would result in trying to take an even root of a negative number. You just can't do it. Okay? Now, later, toward the end of the course, we'll come up with one other exception. And there are more, perhaps. But this one is logarithms. We haven't gotten there yet, but when we get there, you'll see. Anyone know already what restrictions are with logarithms? Sort of like this one. You can't take the log of a negative number. Neither can you take the log of 0. So that would have an open parenthesis here. Okay? Now, guess what? They'll throw some mixed things at you. They'll put x's in the denominators inside square roots. So then you have other things to worry about. But they're not bad. Okay. Any questions on that? Say this again.
Don't look to this page and write down.
Oh, okay, got it. Okay. And it's perfectly fine to do this if you don't like writing that much. The PowerPoints are all out there on Blackboard. You can print them off ahead of time if you want to. But I kind of like writing them myself because that is more of an active learning process than just reading it, which is more passive. So, whichever. All right. Any questions so far? So we have explicit domain, where they just tell us, or you have to figure out what the domain is, or an implied domain, which is you look for variables in the denominator and variables under even root signs, even radicals. Now, there is another one we're going to run into in the next example, physical situations. And that's what we're going to get to next. All right, to move? Yeah. Okay. Let's find the domain of each of these functions. Okay? What is the domain of A?
Domain is -3.
Okay. And this will be a set of, goodness, you don't start with a parenthesis, I mean a comma. Set of, and he started saying, -3, -1, 0, 2, and 4. Does everybody see where he got them? Yeah. The domain is the first number in an ordered pair. So there they are. Now, just a couple of issues here. Not serious issues. This one happened to list increasing order, and that's fine. You don't have to do that. It's usually a good idea. Okay? Now, another thing, none of these repeated themselves, which is a very good thing, because then it wouldn't have been a function. Unless, of course, the other -3 would have had the same 0 following. You just don't need to list it twice. Okay. So, you're absolutely right. That's an explicit domain. Just pick out the first elements. Those are your domain. Good. How about the next one? What's the domain of G? Only one value for G. Is that right? Say again? Okay, why would you exclude +5? -5. You're absolutely right. Now, tell me how to write that in shorthand. I did it in set notation here. Let's do it. Set of all x's such that x is not equal to -5. That is a good shorthand way of writing it. What's the other one? The interval notation. Okay, don't list them all, please. Think of your number line. What values can go on it? Every number except -5. So, where do you begin? -infinity. And what symbol precedes that? Parentheses, -infinity, up to -5. And what symbol follows that? Parentheses, union, parentheses, -5 to positive infinity. That's it. That's interval notation. This is set notation. All right, here we hit our other one that you have to do a little thinking on. Here's the volume of a sphere. This is a physical formula, an equation, okay? Volume of sphere is V is equal to 4/3 pi r cubed. Volume of any sphere, what is your R there? Anyone know? The radius of the sphere, exactly. Now, what's your domain? These aren't x, y's, we're not seeing. What is your domain here? Set of all possible values for which variable? R, because that's your input. Give me a radius, I can give you the value. Give me another radius, I'll give you that value. That's the input, okay, is the R, the independent variable. What values can R take on? What's our usual first assumption? All real numbers, except what? Okay, except 0. Yeah, if you had a 0 radius, you don't have a sphere at all, do you? Try shooting a basketball with a 0 radius basketball. Can't do it, okay? What other do you have to exclude? Negative. Can you draw me a sphere with a negative radius? No, okay? So what is your domain? Okay. No, okay. Okay, I got it. You're doing the interval notation from 0 to Now, I guess infinity, okay? What's the biggest ball you can make? I don't know, but, you know, it just keeps going. Okay, how do you express that in set notation? How would you do it in set notation? The curly Q is called a brace, okay? What follows that? Set of all R's such that R is greater than 0. You can't have a negative radius, you can't have a 0 radius. You don't have a ball then, you don't have a sphere. So there's how you would express it in set notation. In this case, interval notation is a little simpler to write. Now here's the reason I don't care for set interval notation, because if this had actually been a number here, like 75 or something like that, then that looks like a point on a point. Usually when you have an ordered pair, that's how you write. This says, that's a set, okay. This is, you have to read by context that that is a set. All right, how about H? What is the deal with H? Any ideas? Have an idea, somebody. What you reckon? Okay. You think it's all real numbers? I doubt it. What's your restriction? What can you never do? Say again? Okay, you cannot take the square root of a negative number. Well, what's under the square root sign? What is under the square root sign? 4 minus 3x. And what do we say that can't be or could be? It has to be, and you write that as greater than or equal to 0. That means it's positive. Or 0. It's all right to have a 0. Can we get your name, please? Second? Fitzpatrick. Okay, got it. John, right? Is that right? John? Yeah. Good deal. Did anyone else come in while I wasn't watching? Okay. All right, so there's where we start. Whatever is under the radical cannot be negative. And here's how we write it. It must be greater than or equal to 0. That means it's got to be 0 or positive. Can't be negative. Okay? Make sense? Now, what do you reckon we're going to do now? We don't care what the expression is. We want to know what values x can take on. That's your domain. So what are we going to have to do? They're children's, got it. Okay. Let me make sure I've been pronouncing your name right. When I saw it spelled, I went, have I pronounced that right? You go by Minuet or Minuet? Minuet? Yeah. Okay, that's what I thought you had said. My hearing's so bad I don't trust it. Okay. Well, I'll still mark you present, whatever you call it. Okay. All right. So what you reckon we're going to do here? Solve for x, exactly. Now this is an inequality, but you use the same type rules up to a point anyway. So what would you do first to solve for x? Subtract 4 from both sides of the equation. Excellent idea. That goes to 0. You get minus 3x has to be greater than or equal to negative 4. Now what? Divide both sides by negative 3. Okay, do any bells and whistles, warning signs go off in your head? You have to change the direction of the inequality. Absolutely. If you add or subtract positive or negative numbers from both sides of an inequality, no problem. You keep the sign the same. Okay? If you multiply or divide by a positive number, keep the direction of the inequality the same. But if you multiply or divide by a negative number, you flip that inequality. So this would become x is less than or equal to what? Help me. Which is shorthand? Negative by negative is? Positive 4/3. Less than or equal to 4/3. Okay? Now, frankly, to me, if I say, what's the domain? That's it. Okay? But if you write it in set notation, what would that be? There's a brace, set of all x's such that x is less than or equal to 4/3. Okay, that's why I just assume to say x has to be less than or equal to 4/3. That's fine. All right, how do you do this in interval notation? A bracket? Okay, where do you start? On the left. If you start writing right to left, I'll think you may be Japanese. Okay. What's that? It starts, and what symbol precedes negative infinity? Parentheses, negative infinity, to 4/3, and now it's the bracket. Perfect. Okay, because you have the equality sign here, so you do put the bracket. Make sense? All right. That's how we did it. Let's see how the book did it. All right. On the first one, the domain of F, go back and see F. The domain of the F is a set of all the first values, okay, which was, we said, was -3, -1, 0, 2, and 4. They said -3, -1, 0, 2, and 4. They got it right. Good for them. Okay? Make sense? Any questions? Okay. The B one. The B one was that one that you were dividing by x plus 5. And they said, excluding the x values that yield 0 in the denominator, the domain of G is a set of all real numbers x except x equal -5. Okay? That's exactly what we said. They wrote it out in a sentence. We did it otherwise. Let me show you how I do it. You don't have to do it this way, but you just gave it to me, okay? So I wrote it down. Here's what I would have done if I was really serious about showing all the steps. Here's your denominator, x plus 5, can that equal 0? Then subtract 5 from both sides, and that gives you x cannot equal -5, which is exactly what we said there, okay? So, yes? Okay, if you write it like this, and asking for the domain, and that's correct, if it's a correct answer, I give you credit for it. Okay? So, yeah. You don't have to do it in either one of those. The reason I show you these is that, say, the answers in the back of the book, they're probably going to be in this form, not that form. So I want you to be able to recognize, oh, yeah, that's what they're saying. Okay. Yeah. All right. So that's exactly what they did here, except they wrote it out as a sentence. You can write it out as a sentence as long as you do it right. Okay? Now the C one. The C one is that volume of the sphere. Because the function represents the volume of the sphere, the values of R must be positive. Not non-negative, positive. You can have a zero sphere, so it has to be positive. So therefore the R, any value greater than 0. The domain is a set of all real numbers R such that R is greater than 0. That's written out as a sentence. We could have done it very shorthand. Okay. Questions? Okay. And then the D, the one we just did, this function is defined only for x values for which 4 minus 3x is greater than or equal to 0, because that was what's in the radical, has to be positive or non-negative, so greater than or equal to 0. Then you solve that and you get x is less than or equal to 4/3. They didn't show you how they got that, they just said, there it is, okay, we did it. Make sense? All right. So now they write it, this one, that's fine. Any value set of all x's between negative infinity and 4/3, including the 4/3. So that's why you have the bracket as the endpoint because of the equality sign there. Any questions? That was fun, wasn't it? Okay. Now, notice in example 7c, the one we've talked about a lot, the domain of a function may be implied by the physical context. You cannot have a sphere with a negative radius. So that the physical context also implies a domain. If you're talking about how far did you travel? Can someone travel a negative distance? No, you're traveling some positive distance. Okay. Lots of things physically typically are always positive. Okay. So, for instance, from this equation, you would have no reason to restrict it. Okay. If they had just given you the equation without saying this represents the volume of the sphere, then you would say all real zero, all real r's. But we know that's a thing. So if they just said the equation without any description of it, then you could say, oh, any real number r will work. Okay? But if you know that's the volume of the sphere, then you only have it. You cannot have a negative or a zero radius. Okay. The next subtopic here is applications. They're going to do the first one, we'll do the second one. Okay? Now, you're working in the marketing department of a soft drink company and are experimenting with a new can for your iced tea that is slightly narrower and taller than the standard can. Now, I can remember back when I was in some sort of probably junior high or something, I remember a teacher giving an example like this and saying, giving the phrase, marketers always try to fool consumers by making a can taller. Because that looks like you got more iced tea than if you had a shorter, it's just slightly bigger can. It really, most of the time, the taller doesn't mean you have more. Unless, of course, they were the same radius. And we'll see why in just a second. For your experimental can, now here's a key. The ratio of the height to the radius is 4. Okay? When you see a sentence like that, especially if you have the illustration like this, here's your can. We call that a cylinder, right? Circular cylinder. Circular because the top is circular. Right circular cylinder. And the height is h and the radius is r. Well, let's see what this says. The ratio, someone tell me what ratio means. Comparison in a division sense. So the ratio of the height, that means you put h on top, to the radius on bottom, that translates as equal to 4. That sentence there translates in the math to be that sentence there. That equation right there. Make sense? And that's where they got this. They just wrote it down, but you get it right from this. Ratio of height to radius, and h divided by r, is equal to 4 is 4. Okay? Most of the time you can translate directly like that. All right. Now, it says write the volume of the can. Time out. Does anyone know the volume of a right circular cylinder? Okay. Let me give you the general equation for the volume of any standard shape. Okay? And I say a standard shape because this has a height and it has a fixed base. The base all the way up and down is what? What shape is that? A circle, okay? I would have to, of course, show that, but you might fill out. Okay. It's a circle, right? Okay. So, the volume of any regular base, any regular shape, is the product of the area of the base, that's why I put it a capital B, times the height. That's what a volume is. Area times the height. If it's a regular shape, it's the area of the base times the height. What was the base? What did you say it was? A circle. What's the area of a circle? Anyone know that one? Area of a circle. Say again? Area of a circle. Yes, exactly. I always thought pi were round, but you said pi r squared. Okay, no, never mind. Pi r squared, that's the area of a base, times the height. There's the volume of a right circular cylinder. Okay? Now, if you didn't want to remember all that, you didn't have to, but I wasn't going to tell you ahead of time. In the back of your book, the back inside cover, here are several formulas from geometry. Here's the right circular cylinder. The volume is pi r squared h. So there's the radius, there's the height. So it's in the back of the book. A lot of these things are easily found, but that wasn't hard to think through either, was it? All right, so there I've written the volume as a function of radius and height. Now, pi is just a number. That's perfectly okay to have. We want it only as a function of the radius. So what do we need to do? And hint, you're going to use that. If you want that volume as a function of radius only, get the height as a function of the radius. And what would that be? How can you get height as a function of radius? Multiply both sides of this equation by r. That wipes it out of the denominator, and that gives you h is equal to 4r. That's a function of the radius. Okay? Now, plug that in for the h. So now we have v is equal to pi r squared, and the h is 4r. Right? That's what h is. Now, get the constants in front. 4 times pi, 4 pi, and you got r cubed. There's the volume as a function of radius alone. 4 pi r cubed. That's given that you have that ratio. Okay. Any questions on this? Does that make sense? You want the volume as a function of radius alone, get that other variable, height, as a function of radius, which we did based on that relationship that gave us. Ratio of height to radius is 4. Okay? Any questions? All right. Now it says write the volume of the can as a function of the height alone. Uh-oh. What must we do then? See, our basic formula has both radius and height. So now what we want to do is get the radius as a function of height. How do we get that? Let's use the same form we just had. How will you get radius as a function of height? We want to isolate the radius. How do you do that? Anybody, help me. You want? Say again? Okay. Says down here we want to write the volume of the can, which is pi r squared h, as a function of h alone. See, this has an r in it and an h. So we don't want r, we want only h's. So what must we have? We must get radius as a function of the height. Okay? Say again? Yeah, radius as a function of height, right? Okay? Now, you could have used this one, but that's difficult. We just came up with this. That's real easy to solve for r. Say again? Isolate the r. What do you do? Divide by 4, exactly. So this gives you divide both sides by 4, and the 4's go out, and you get radius is equal to h over 4. So, what we do here is substitute in our original formula, v is equal to pi, that's just a number, times your r is now h over 4. Is there a question? Okay, is there a question?
No, sir.
Okay. H over 4 squared times h, right? Instead of r, we put h over 4, we have to square it. So what does this give us? Okay? What does this give us? Pi. We're going to leave that alone. When you square h over 4, what do you get? Square h squared. Square 4, you get? No, you're not squaring pi. It's squaring the 4. 16 times h. Okay, now get the numbers together. That would be pi over 16, and then you have h cubed. There is your volume as a function of h alone. Here's volume as a function of r alone. That's given that you have that relationship. Okay? Does that make sense? All right. Any questions? You want to see how they did it?
Yes.
Okay. Here is your volume as a function of radius and height. That's from the back of the book, pi r squared h, exactly like we got, right? What they did, without telling you or showing you, they used that h over r is equal to 4. They rewrote that in terms of h is equal to 4r, plugged that in for h, and that gave you pi r squared times 4r, because the ratio of h to r was 4. Okay? Then you combine your numbers together, 4 pi, and then combine your r's together, you get r cubed. There's your volume as a function of r alone. Okay? Does that make sense?
Yes, sir.
It came from the fact that the ratio of height to radius was 4. Okay, on the B part, you start with that same formula, but this time you want it as a function of h, so you got to get the r in terms of h. And if 4r was equal to h, then r would be h over 4. But that r is being squared. You take 4r is equal to h divided by 4. You get r is equal to h over 4. And you plug that in for this r, and you get h over 4 squared times h, which would be, and they just skip right to the answer. Now they put the whole thing over 16, or you could put the pi over 16, it doesn't matter, times h cubed. Make sense? Hey, they skipped a lot of steps, but hopefully we picked them up. Any questions? All right. Okay.
My neighbor's name.
What's that? And by the way, I didn't say it before, but I'll say it again in case anyone missed it earlier. Every example in the book is followed by a checkpoint. And as soon as you get out of class and have a little bit of free time, try to do the checkpoints of the things we did in class so you can reinforce what we did, make it yours. If you have trouble doing it, the audio-video solution is found at larsonprecalculus.com for every checkpoint. So if you can't remember how we did something, go there. You can see and hear what they did. Okay, everybody got it? All right, I think that, oh no. Well, they're going to skip example 9, so let's go back and do example 9. We'll do it right here. All right, a batter hits a baseball. All right, good. I never do. Okay, never mind. At a point 3 feet above the ground, at a velocity of 100 feet per second and an angle of 45 degrees. Now, I can't draw good batters and balls and things like this. I'll give it my best shot here. Here's the batter with a baseball hat and everything else on, you know. That's not very good. Okay. He's got a bat in his hand. Okay. Ooh, that's a bad bat. Okay. And come down here, and he's going to swing and hit the ball 3 feet above the ground. That's right about waist level, right? And when he hits it, it's going to take off at 100 feet per second. That's going to be its velocity. You don't have to draw your thing. That's the velocity. And the angle it's going to take off is 45 degrees. Now, that's just to give you. Okay. Now, the path of the baseball is given by this function. F of x is equal to negative 0.0032 x squared plus x plus 3. Okay. Now, they just gave that to you. You didn't have to derive it. I'll give you a little bit of a clue of how they did that, but not the full thing. I know this is, or at least I suspect that's a good thing here, because hopefully some of you have either had physics or will take physics in the future, and you know that the distance the ball has traveled is related to the acceleration due to gravity, and when you're dealing with feet per second, that's 32 feet per second squared. How did that get down there in the way? I don't know. Okay. 32 feet per second squared. Now, where all those decimals came from, you're dividing by 100 squared, so that's why the decimal is moved way over there. Normally, you have the 100 here, the velocity next to x. We don't have that, so because we divided by it. But the height of the ball, when x was equal to 0, was 3 feet. So this is, x is the range of the ball, how far the ball has traveled, and this is the height of the ball as it's traveling there. Okay? So where f of x is the height of the ball at any point x, and x is the horizontal distance. From home plate. Okay, I wrote those words together. I shouldn't have. From home plate. That's what we've got here. Now, here's the question. That's the setup. Here's the question. Oh, that distance is in feet too, because this was in feet per second, so you have your distance in feet. Okay. Here's the question. Will the baseball clear a 10-foot fence located 300 feet from home plate? So we're going to have to foreshorten this. Somewhere out here is a 10-foot fence. Okay? And this is 300 feet from home plate. Okay? There's the fence. So obviously I'm not drawing the scale here. Okay? 300 feet to the fence. Will it clear the 10 feet? Well, the 10 feet is the height of the ball, and the 300 feet is the distance from home plate, right? So the 300 will represent the x, and the f will represent the height. So basically all we have to do here is decide, will that work? So plugging in x equal 300, let's see what we get. See what height we get. Negative 0.0032 times 300 squared, and by the way, that's 300 feet squared, plus 300 feet, that's your x, plus 3. And the height of the ball originally was 3 feet. So this was 3 feet to begin with. Okay? Now, pull out your calculators, or you can do it without a calculator if you want to. Negative 0.0032 and 300 squared. Anyone know what that is? 0, 0, 0, 0. 90,000, okay? Because you square this 3 and you double the number of zeros from 2 to 4. Plus 300 plus 3. Okay? Now, when you multiply these together, these 4 zeros will wipe out your decimal here. So basically you just have 9 times 32, which would be 1828. That's a negative 288 plus 300 plus 3. Okay? Hopefully you can do that in your head. Negative 288 plus 300 would be 12 plus 3 equal 15 feet. So the ball is going to wind up here. 15 feet above the fence. Yes, it will clear that 10-foot fence. Now, can that center fielder or right fielder, left, whoever it is out there, you think he can jump up and catch it at 15 feet? Not me, okay? I don't think it is. If he could, he shouldn't be playing baseball. He should be playing basketball, all right? Okay, never mind. All right. Make sense? All right. All you do is plug it in, plug it in. And you can use your calculators to do the squaring and stuff. You don't have to do it in your head like I did. Now, that brings us to another point. I think I mentioned this when we went over the syllabus. Please, on test day, please bring your own calculator. I don't have any extra calculators, and know how to use it, because that's the worst time to try to figure out how to use a calculator. Know how to use your calculator and bring it so you can make your way through it. So, by the way, that's what the book got. Good for them. There is a checkpoint. Do that as soon as you can after class. All right. There is yet another example that they skipped. And this one I think we're just going to talk through, sort of. Okay? Now I'm going to, anyone need this a little longer? I see a few people still writing. This is the kind of problem, this next one, I really wish they would put in the slideshow, so I don't have to hold the book up. But I'm going to hold the book up if I can. Everybody got it? Okay. Now, I'm going to clear my writing so that you'll have more white space to see what I'm talking about. Got to get rid of that. Okay. I'm not going to be able to hold this long. But the number of fuel stations that sold E85, anyone know what that stands for? E85. Gasoline, by the way. The E means ethanol, but 85 means how much gas, 15% ethanol. So they sort of mislabeled it. Seemed like they should have called it E15. But they call it E85, and it's 85% gas and 15% ethanol. In the U.S., increased in a linear pattern from 2008 to 2011. So you see from here, 2008, they didn't write out 2008, they just put the 8. So there's 2008, 2009, 2010, 2011. So between those years, it increased at pretty much a linear pattern. You could almost draw a straight line through that, but that would miss these. So we put that for the first, 4 years, we put this formula, and then a different linear pattern between 2008, 2012, and 2015. So there's another linear pattern there. I can't hold it any longer. Okay. So that gives us this piecewise defined function. Okay. Now these are approximate. Okay. These are approximated by this function. So here's that piecewise defined function. S, which is number of stations, T is number of years, or the year number, okay, would be, and this is years after year 2000, 260.8 T minus 439. Okay, that's for every year between 8 and 11, including the endpoints. A different slope, 151.2 t plus 714, that's for years 12 to 15. So 2012 to 2015. Okay, that's your piecewise defined function, where t represents the year, with t equal 8 representing 2008, t equal 11 would be 2011. Okay. Use this function to approximate the number of stations that sold E85 each year from 2008 and 2015. You know what? I don't want to do them all. Let's do just a few and we'll see what we get. So I say, give me a year. Something between 8 and 15. Give me a year. Say again? 11. Okay? So, what we're looking for is S at 11. Okay? This is just like we did before. The first question you do is, where are you, Waldo? Where are you up there? First or second form? The first form, because the t equal 11 is up there, so you plug it in here. And you plug in 260.8 times 11, because that was your t, remember this is your t, minus 439. Okay? Someone pull out the calculator. I'm not going to do this one in my head. Pull out a calculator and plug it in. 260.8 times 11 minus 439. I think it is. Yeah. Say it a little longer? A little louder? Yeah, minus 439. Yeah. 2,000. Say again? 429. Okay. Okay, now, let me go back and see one more thing. If you look at the, yeah, okay. Now, you said 0.8. How many times you run into 0.8 service stations? You don't. So let's round that up to 2430, okay? Because 0.8 is more than 5. So we'll make it 30. This would be the number of stations. Let's see what they got. 2430. Good for them. Okay? Give me another year. Say again? 14. Okay. So S of 14. Where are you, Waldo? What? Which one do we use? The second one. That would be what? 151.2 times 14 plus 714. At least I hope I wrote it right. Let me get these out of the way. What do you get then? Okay, are there any questions? Are there some questions? Are there questions? Okay. Say again? 2,000 what? 831. You rounded up to 31. Let's see what the book got. Yeah, 2831. Good. Now, do you think we need to do all those? Please say no. Okay, good. All right. You see how to do it? If they're anything between 8 and 11, plug in the top equation. If they're between 12 and 15, plug in the bottom equation. You did one of each. Good job. Got them both. All right. So there is another example of an application. And guess what? They have a checkpoint. So you can follow that. Now we're ready for the next topic, a difference quotient. Is this something new to you, or have you done these before? New? Guess what? You've done them before. I bet. I will bet you've done them before. What does the word difference mean to you? Well, operation in math. Subtraction. Quotient means dividing. Have you ever subtracted and divided in one problem? I bet you have. Okay, let me give you a hint. Have you ever calculated the slope between 2 points? How do you do that? Change of y over change of x. Change of y is a difference, divided by quotient, change of x, a difference. Yeah, you've done these before. Difference quotients. That would give you a slope. Okay? So one of the basic definitions in calculus, and this is for calculus algebra, employs this ratio. Now, remember back a few classes ago, that one of the key things to remember about functions. What is your f of x? Important thing to remember. What is f of x? Oh, y'all forgot that already. You had too long a weekend, didn't you? What was f of x always? Y. Why not? No, y. So this is y2 minus y1 over the difference between x plus h and x minus h. I mean, x plus h and h, the difference between that, x's go out, there's your h. There's a difference quotient. A difference up here, a quotient here. Okay? Now, of course, h can't be 0 until you get the calculus. No, it still can't be 0, but you can do a limit then that's x approaches 0. So that ratio is called a difference quotient. It's illustrated in problem 11. Example 11. Okay, here's example 11. Okay, do we have time? Hey, what time is it?
9:38.
30. Hey, yeah, we got time. Goodness gracious. Okay. So here's your example 11. Here's your function. F of x is equal to that. Find the difference quotient. Okay, now before we do anything else, we got to find what this is. What is f of x plus h? How do we do that? Now that was before the holiday too. How do we do that? Oh, how soon we forget. Say again? Well, where you see an x up here, you put x plus h in its place. So that would be what? X plus h squared. Continue. Minus 4 times x plus h plus 7. There it is. Now you just have to figure out what that comes to. So let's do it. Why do you square x plus h? I gave you a shortcut before. If you need to, you can go off to the side and do it the long way. Anyone remember? X squared, square the x. Then you do twice the product plus 2xh. Remember? Not? Okay, remember? And then what's the last part? Square the last plus h squared. Okay, let's do the next part. Distribute the minus 4. What do you get? Help me, somebody. Minus 4x. Next. Minus 4h plus 7. All right. There's your f of x plus h. Okay? Now, I'm going to write that down here. That would be x squared plus 2xh plus h squared minus 4x minus 4h plus 7. Okay? That's this part. Okay? Now I'm going to subtract my f of x. Well, here's your f of x right here. Right? So let's subtract that. Minus x squared minus 4x plus 7. Okay? And then we're going to divide this by h. Okay? Now, notice I put, excuse me, is there a question? Excuse me. Okay. Now, notice I put anything following the minus sign in parentheses, because you have to negate everything inside. So that's the next step, is get that numerator squared away. That's going to be x squared plus 2xh plus h squared minus 4x minus 4h plus 7. I'm tired of writing that one. What goes next? Minus x squared plus 4x minus 7, all divided by h. Okay? Now, at this point, let's see if we can combine like terms. Excuse me. Okay? Combine like terms. You see any other x squareds? Yeah, there's an x squared and a minus x squared. Those add to 0, don't they? Okay, I don't see any other xh's. I don't see any h squares. Here's a minus 4x. What else do we have? Plus 4h. Those add to 0. That's good. Well, here we have, there's no other h's, but here we have a plus 7 and a minus 7. They add to 0. Boy, that got rid of a bunch, didn't it? So what do we have now? 2xh plus h squared minus 4h. That's it, right? All that's left in the numerator divided by h. Now, what do you notice we can do with that numerator? What can we do with the numerator? Notice that each term has an h in it. So we can factor it out, right? So let's do that. Factor out an h, and what does that leave you with? 2x, no, factor out an h, plus h minus 4 divided by h. Now what can we do? Divide out the h's. So here's what our difference quotient comes out to be: 2x plus h minus 4. Now that's as far as we're taking it in pre-calculus. Okay? When you get to calculus, then what I was saying before, let's take the limit as h gets closer and closer to 0. So that would come out being 2x minus 4. If x is going closer and closer to 0, that's going closer and closer to 2x minus 4. And that's exactly the derivative of that original function. That's how we're going to do it in calculus. Hopefully some of you will still be around to do calculus, right? Yes. Okay. All right. And I think that's what they got in the book. Let's just see. Let me clear the screen. I know we're running short of time, but we'll make it. Okay. So they first put in x plus h for x and did that one, subtracted off f of x, divided by h. When they multiplied that all out, that's what they got. Same thing we got. When they subtracted, that's what we got. They eliminated the like terms. Added the like terms. You got that. Factor out an h, and then divide out the h, and you got exactly what we got. Any questions? All right. There is a checkpoint. Please do the checkpoint. All right. Now, there's a summary of function notation terminology, a good thing to look at. And there's a summary at the bottom. We'll begin next time with the vocabulary. Are we out of time? Okay. Here's the homework exercises, though. Any of the odds, 5 through 7, they're both at Calc Chat. 7's at Calc View. 9's at Calc Chat. Any of the odds, 11 through 17, all at Calc Chat. 11's at Calc View. Any of the odds 19 to 29, all at Calc Chat. 21's at Calc View. Either 31 or 33, both at Calc Chat. Any of the odds 35 to 41, all at Calc Chat. 37's at Calc View. 43 to 45, both at Calc Chat. 43's at Calc View. 47 or 49, any of the odds 47 to 55, all at Calc Chat. 49's at Calc View. 57 and or 59 and or 61. Well, let's do it this way. Any of the odds 57 through, 71. Okay? Any of the odds 50, was it 57? Yeah, 57 to 71, they're all at Calc Chat.
Or do I have to choose?
No, that sounds good.
Okay.
All right. Let's continue. Any of the odds 73 to 79, they're all at Calc Chat. 75's at Calc View. 81 or 83, both at Calc Chat. There's true false. 85 or 87, they both should be at Calc Chat. Then there's an error analysis, and think about it. You can do those if you want. 89 through 93. We'll pick up with the vocabulary next time.
I just had a question. You did say we wasn't going to use like the web assign, right?
Okay, the web assign is out there for you to use as much or as little as you want.
Okay,
I don't make any assignments on it. I don't grade it, but it's there as an additional tool for you to use to get to practice. Exactly, just like the homework.
And you're not
Gives you
taking
more
the homework
practice.
up?
Huh?
You're not taking the homework up?
Nope. That's your
I can take
practice.
it on the weekend.
Say again?
If I come at 8 o'clock and then I can show it to you.
Yeah,
Take it on.
absolutely. If you have any problem doing it, please come see me. You're at 8 o'clock or anytime during office hours, we'll try to go over. Or ask me in class.
Okay.
I want to hear that too, because more than likely someone else is having problems with it if they had done it. Okay, now, I'm sorry, I didn't say that, did I? Okay.
What section you come from?
This is 4.1. I mean, 1.4, I said it back. 1.4.
1.4 in the book.
Say again?
1.4 in the book.
We can't hear you.
1.4 in the book.
Yeah, right. Okay.